Marinum Wittersand deploys the SeaBin, a floating, pump-driven filtration unit that continuously draws in bottles, cups, plastic fragments, and floating debris while allowing fish to pass safely. Each unit can remove up to half a ton of waste annually, with all collected plastics recovered and sent for responsible recycling. Interceptor 006 delivers a record-breaking performance, capturing 272 truckloads of river waste, an astonishing 1.4 million kilograms, or 3.1 million pounds in a single night. Engineered for large-scale cleanup, the system intercepts floating debris before it reaches the ocean, proving its impact in one of the project's largest river catches to date. Plastic packaging rarely enjoys a dramatic send-off. Most pieces disappear quietly into everyday waste, emptied, flattened, and tossed aside. Separating such complex compositions is difficult, which is why a significant portion has historically been burned for energy recovery rather than turned into new products. In southern Hessen, however, a different vision is taking shape. At a modern sorting facility run by Melo, the objective is not merely disposal, but high-value recycling. The goal is to significantly increase the share of plastic capable of re-entering the production cycle. To achieve that, the plant processes waste collected from a 300-kilometer region, drawing material from Bavaria, Baden-Württemberg, Rhineland-Pfalz, and Hessen. More than 120,000 tons of waste per year arrive here, representing roughly 5% of all yellow bag waste generated across Germany. Yet the incoming material is far from clean. HDPE detergent bottles sit beside PET water bottles and PP caps, but they arrive mixed with non-returnable packaging, food residue, disposable items, broken toys, and general household trash. Effective recycling begins with restoring order to this chaos, and that starts with state-of-the-art sorting. Inside a vast machine hall, the process unfolds along 2.5 kilometers of conveyor belts. The first major machine is a rotary sieve, a giant cylindrical drum whose perforations act as a mechanical filter. Smaller fragments fall through the openings, while larger objects continue forward. Two additional drums refine the size separation, creating 5 distinct material streams. Classifying waste by size is critical. It prepares each fraction for more specialized sorting steps that follow. Lightweight materials, such as film, bags, and foil, are then removed by a high-velocity air separator. By blowing thin plastics out of the stream, this stage clears the way for accurate recognition of rigid plastics. The cleaner the flow becomes, the more effective downstream plastic sorting will be. Next comes the heart of the operation, near-infrared (NIR) optical scanners. These devices identify different polymers by their spectral signatures. In milliseconds, the scanners register the type of plastic passing beneath them. Targeted blasts of compressed air then shoot specific objects out of the mainstream. First, PP caps are separated. PET containers follow. Finally, HDPE bottles are isolated with remarkable accuracy. This automated precision dramatically enhances purity levels, but human expertise still plays a role. Workers stationed along the belts perform quality checks, removing contaminants and ensuring that only recyclable items continue forward. Despite the advanced technology, roughly 1/3 of the initial material remains unusable. Mixed plastics, wood fragments, textiles, and miscellaneous objects ultimately go to energy recovery incineration. Yet the remaining 2/3 represent a valuable resource. The Gernsheim plant subjects these plastics to more than 30 sorting procedures, yielding HDPE, PP, and PET bales with purity levels between 94 and 98%. Such well-sorted material is highly sought after by manufacturers in Germany and neighboring countries. HDPE can be transformed into durable pipes or industrial pallets. PP frequently becomes buckets, crates, or horticultural products. PET is converted into textile fibers for fleece garments or into weather-resistant outdoor furniture. These products demonstrate the versatility of recycled plastics, yet they also highlight a limit. Many applications constitute downcycling, where materials degrade in quality and eventually return to waste streams, bound for incineration. A true circular economy requires that a bottle become another bottle. Achieving that purity demands a second stage of processing, carried out at Systec Plastics in Eisfeld, Thuringia. Here, selected HDPE bottles are shredded into flakes and thoroughly washed to remove every trace of shampoo, detergent, yogurt, or other residue. Additional separation techniques eliminate paper labels, metal rings, and stray contaminants. The remaining flakes must then be sorted by color. Without this step, the melted output would be a murky gray, unsuitable for high-grade packaging. Color sorting is performed with extraordinary precision. Tens of thousands of flakes per minute slide past lead arrays and high-speed sensors. Each flake is identified. More than 60 compressed air nozzles instantly remove unwanted colors. The process repeats across multiple sorting tracks, ensuring exceptional accuracy. The result, 800 kilograms of HDPE flakes per hour, exceeding 99% purity. These purified flakes enter an extruder, where they melt at 220 degrees C before passing through fine filters. Once cooled, they solidify into uniform plastic granules, high-quality secondary raw materials suitable for use throughout the plastics industry. PP caps undergo a similar transformation, ensuring consistent material streams for future manufacturing. Each year, approximately 20,000 tons of yellow bag material is processed in Eisfeld. Only part of it receives the full treatment, but expansion plans aim to increase capacity and raise purity standards further. The ambition is clear: to create recycled materials clean enough for cosmetics, and eventually safe enough for food packaging. One major user of these recycled materials is Werner and Merz in Mainz, manufacturer of cleaning and detergent products. Here, HDPE granules from Eisfeld feed into extrusion blow molding machines. The plastic is melted, shaped into parasons, and inflated into new bottles. Excess plastic is trimmed, leaving containers that look and perform like those made from virgin material. Each year, 5.5 million HDPE bottles are produced entirely from yellow bag recycling. PP caps made from 100% recycled material complete the packaging. PET bottles also incorporate recycling. Although current yellow bag PET supplies are limited, they are blended with PET from deposit return systems to ensure consistent quality. More than 80 million PET bottles are produced annually using this hybrid approach. Over time, rising availability of high-grade recyclate will allow the share of yellow bag PET to increase. What once would have been burned now returns to productive use. And while the transformation may appear unspectacular, a single bottle sorted, shredded, melted, and reborn, it represents meaningful progress. One bottle reclaimed, one step closer to a fully circular plastics future. The Pontiac Firefly built its reputation as a stubborn little survivor, clocking more than 300,000 kilometers through snow, ice, sleet, and every harsh road condition imaginable. But toughness takes on a new meaning when it meets the Caterpillar D11, one of the largest and most powerful bulldozers on Earth. With its 1,000-plus horsepower engine, massive steel blade, and a frame built for mining and heavy earth moving, the D11 represents unstoppable force. In this dramatic face-off, the lightweight Firefly becomes a symbol of endurance, while the D11 shows what true industrial power looks like when steel meets steel on uneven ground. The ATR 300 tire recycling plant showcases a modern, highly automated approach to turning end-of-life tires into valuable secondary materials. The process begins as whole car and light truck tires are fed onto the infeed conveyor, where a heavy-duty pre-shredder reduces them into manageable chunks. These pieces move directly into the ATR 300's primary granulator, a precision-engineered rotor equipped with wear-resistant blades that cut the rubber down to a consistent intermediate size. Throughout the line, robust steel screens control particle dimensions, ensuring only correctly sized fragments pass to the next stage. As the material flows forward, a powerful magnetic separator extracts steel wire embedded within the tire carcass. This recovered steel, clean, uniform, and ready for reuse, can be sold to metal recyclers or returned to industrial processes. Next, a series of high-speed mills and refiners further downsizes the rubber, transforming coarse granules into fine crumb with particle sizes tailored to customer requirements. Integrated dust extraction units maintain a clean working environment and stabilize product quality by capturing airborne rubber dust. Separation efficiency is central to the ATR 300's performance. After each grinding stage, air classification units and vibratory screens work together to isolate pure rubber from textiles and residual contaminants. The textile fibers, once removed, are compacted for easy handling, while the purified rubber granulate is conveyed to the final collection bins. Every step is monitored electronically, allowing operators to adjust cutting speeds, rotor temperatures, and screen selections in real time for maximum throughput and minimal energy consumption. The finished rubber granules emerge uniform, clean, and ready for use in a wide range of applications, including playground surfacing, athletic tracks, molded rubber products, and asphalt modification. By transforming discarded tires into high-value materials, the ATR 300 tire recycling plant not only reduces landfill waste, but also supports a circular economy, where resources are continually recovered, refined, and reintegrated into new products. At Volkswagen's first pilot plant for EV battery recycling in Salzgitter, Germany, used battery packs arrive to begin a carefully controlled recovery process. Each pack is unloaded, tested, and safely discharged, with any healthy cells preserved for second life applications. The remaining modules enter a multi-stage materials separation line, starting with industrial shredders that break the batteries into a moist mixture of granules and chemical compounds. This mass is then dried, allowing technicians to pump out the remaining electrolyte. Once dry, the material is sifted to isolate the valuable black powder, a concentrated blend of lithium, manganese, cobalt, and graphite. The process yields clean fractions of plastics, mixed aluminum and copper, and recoverable battery metals, enabling Volkswagen to reclaim up to 95% of each pack. On July 11, 2011, the demolition of the Miss China, a 67-foot former commercial fishing vessel, unfolded as a rare look into how aging wooden boats are responsibly dismantled. The vessel carried an unusual history. Built in the mid-1960s as a shrimper, its wooden hull had later been sheathed in fiberglass. By December 2010, it had become the floating home of Nantucket scalloper Joe Dowley and his 4 dogs. But after breaking free of its mooring during a winter gale and grounding near Brant Point Light, the abandoned boat became the town's responsibility. With Dowley unable to fund the recovery, Nantucket hired Tucker Roy Towing and Salvage of Fairhaven, Massachusetts, to remove the vessel and tow it to New Bedford Harbor. There, the Miss China sat for 7 months, while crews stripped the boat of hazardous materials and reusable components. Fuel, oil, and any remaining pollutants were pumped out. Rigging, wiring, and functional hardware were salvaged, and the engine, long beyond repair, remained in place until the final teardown. The demolition sequence began with the vessel lifted into the slings of a 400-ton marine travel lift. Suspended high above the yard, the boat was carefully lowered into a hopper barge positioned beneath it. Secured with boat stands, the barge was moved north, toward the Route 6 swing bridge, where a high-reach excavator, equipped with massive hydraulic shears, stood ready. The next day, demolition commenced. Operator Johnny Roy worked with practiced precision, carving into the fiberglass-clad hull. The fiberglass peeled away like onion skin, exposing the aging wooden structure beneath. His brother, Conrad Jr., coordinated the workflow and salvage operations. As the wheelhouse opened, Johnny lifted the ship's wheel intact for recovery. All bronze and brass fittings, along with copper wiring, were pulled aside for reuse or recycling. Scrap metal was separated and staged for proper disposal. With the superstructure removed, the excavator reached the fuel tanks, generator, and engine, extracting each component from the expanding cavity of the hold. As layers of the boat came apart, unexpected artifacts surfaced, small reminders of the vessel's long life and varied owners. By the end of the day, the Miss China had been reduced to a neat pile of wooden debris, destined to be transported north and eventually burned as fuel by a waste processing service in Maine. For a once hard-working wooden shrimper, it was a quiet, unsentimental finale, yet one carried out with methodical care and respect for safe, environmentally responsible dismantling. Causey Recycling, Chicagoland's premier full-service scrap metal recycling company with nearly 80 years of industry experience. The Causey name has long been synonymous with reliable, efficient, and environmentally responsible scrap metal processing. Operating 2 facilities in Bellwood and Melrose Park, Causey Recycling buys, processes, and sells all grades of metal, supplying both ferrous and non-ferrous materials directly to steel mills and other industrial end users. At the Bellwood non-ferrous warehouse, over 100 commodities are processed, including aluminum, brass, bronze, copper, lead, zinc, stainless steel, and nickel-bearing alloys. Materials arrive containerized or loose, and every load is tracked with detailed photographs and scale records, ensuring precise traceability from arrival to shipment. The steel yard is designed for high-volume operations. Trucks follow a circular flow, stopping first at the scale, where yard rules and personal protective equipment requirements are clearly posted. After unloading, materials are inspected and graded. Obsolete metals such as refrigerators or bicycles are shredded, separating ferrous from non-ferrous metals. Non-ferrous products pass through a separation system, creating shredded aluminum, shredded stainless steel, and a non-metallic fraction. Dust and debris are carefully controlled through aspiration and water systems. I-beams and other heavy metals are processed through vertical shears to meet mill specifications. At the Melrose Park drive-through facility, the public can sell common scrap materials, including appliances, copper piping, and aluminum siding. Causey Recycling's truck fleet is GPS tracked with dash cams for efficiency and safety. Containers can be custom fabricated to client needs, and pickups are coordinated with precision. Every step emphasizes accountability, safety, and resource recovery, showcasing a modern, highly organized approach to scrap metal recycling. The Starlinger RecoSTAR Dynamic 105 CVAC, a cutting-edge recycling line designed to transform heavily contaminated or moisture-laden plastics into high-quality regranulate. This system excels with post-consumer materials, making it a versatile solution for modern recycling demands. At the heart of the line is a durable, high-performance single-screw extruder, capable of handling large volumes of material while maintaining consistent output. The CVAC degassing module enhances purification by removing volatile contaminants, inks, and odors, increasing the melt surface by up to 300%. This ensures the polymer is exceptionally clean, ready for high-quality applications. Material preparation begins with Starlinger's Smart Feeder, which shrinks, cuts, mixes, rotates, and temperature controls the input before extrusion. The innovative spin feed technology introduces material with a controlled spin, improving throughput and stabilizing the extrusion process. The dynamic automation package continuously adjusts extruder speed according to fluctuations in bulk density, moisture, or particle size, allowing the line to pause and resume seamlessly whenever needed. Contaminants are removed through a continuous melt filter, equipped with optional backflushing for heavily polluted streams. Downstream, the line accommodates various pelletizing methods, including automatic strand, water ring, or underwater pelletizers, depending on polymer type and product requirements. Extensive testing confirms that the CVAC line removes more than 99% of common contaminants, including toluene, chlorobenzene, and benzophenone. For food-grade PET, or HDPE, the process complies with stringent EU regulations, enabling genuine bottle-to-bottle recycling. The RecoSTAR Dynamic 105 CVAC represents a robust, automated and scalable approach to plastic recycling, turning challenging post-consumer waste into valuable raw material. It supports circular economy goals, reduces environmental impact, and enables recycled plastics to meet the high standards required for new applications. At Ash Pallet Management Inc., recycled wooden pallets meet the highest standards of quality, sustainability, and efficiency. With over 250,000 square feet of indoor storage across 5 acres, Ash offers the largest indoor pallet inventory in the Midwest, ensuring rapid response to fluctuating supply demands. Advanced eco-friendly extermination processes maintain the highest health and quality standards. The facility provides 6 grades of reconditioned 48 by 44 way entry GMA pallets, alongside custom, combo, and new pallets. Precision is enhanced through state-of-the-art robotic dismantling, sorting recycled materials to exact specifications. Every pallet is part of a closed-loop sustainable system, transforming used materials into reliable, reusable products that support clients, operational efficiency, and environmental goals.